Let's suppose that we've carried out the observational study of smoking cessation methods. We're trying to determine which method works best: drugs to alleviate nicotine addiction, therapy, combined drugs and therapy, or simply quitting. The explanatory variable is the method, while the response variable is eventual success or failure in quitting. Our study shows that the percentage succeeding with the combination drug and therapy method was highest, while the percentage succeeding with neither therapy nor drugs was lowest. In this example, there is clear evidence of an association between method used and success rate. Can we conclude that the combination drug therapy method causes success more than using neither therapy or drugs?
It is at precisely this point that we confront the underlying weakness of most observational studies. Some members of the sample have opted for certain values of the explanatory variable, method of quitting, while others have opted for other values. It could be that those individuals may be different in additional ways that would also play a role in the response of interest. For instance, suppose older people are more likely to choose certain methods to quit, and suppose older people in general tend to be more successful in quitting than younger people. The data would make it appear that the method itself was responsible for success, whereas in truth, it may just be that being older is the reason for success. We can express this scenario in terms of the key variables involved.
In addition to the explanatory variable, or method, and the response variable, success or failure, a third lurking variable, age, is tied in or confounded with the explanatory variable's values and may itself cause the response to be success or failure. We could control for the lurking variable age by studying older and younger adults separately. Then, if both older and younger adults who chose one method have higher success rates than those opting for another method, we would be closer to producing evidence of causation. The diagram demonstrates how straightforward it is to control for the lurking variable age by modifying your study design. Notice that we did not claim that controlling for age would allow us to make a definite claim of causation, only that we would be closer to establishing a causal connection. This is due to the fact that other lurking variables may also be involved, such as the level of the participant's desire to quit. Specifically, those who have chosen to use the drug therapy method may already be the ones who are most determined to succeed, while those who have chosen to quit without investing in drugs or therapy may, from the outset, be less committed to quitting.
To attempt to control for this lurking variable, we could interview the individuals at the outset in order to rate their desire to quit on a scale from 1 to 5, with 1 being the weakest and 5 being the strongest. Then we could study the relationship between method and success separately for each of the 5 groups. But desire to quit is a very subjective thing, difficult to assign a specific number to. Realistically, we may be unable to effectively control for the lurking variable, desire to quit. Who's to say that gender and/or desire to quit are the only lurking variables involved? There may be other subtle differences among individuals who choose one of the 4 various methods to quit smoking. And researchers may fail to conceive of these subtle differences as they attempt to control for possible lurking variables. For example, smokers who opt to quit using neither therapy nor drugs may tend to be in a lower income bracket than those who opt for drugs and/or therapy, because they can afford this method. Perhaps smokers in a lower income bracket also tend to be less successful in quitting because more of their family members and co-workers smoke. Thus, socioeconomic status is yet another possible lurking variable in the relationship between cessation method and success rate.
It's because of the existence of a virtually unlimited number of potential lurking variables that we could never be 100% certain of a claim of causation based on an observational study. Observational studies cannot prove causality. On the other hand, Observational studies are an extremely common tool used by researchers to attempt to draw conclusions about causal connections. To do this, great care must be taken to control for the most likely lurking variables. Only then can researchers assert that an observational study may suggest a causal relationship.
So far, we've discussed different ways in which data can be used to explore the relationship or association between two variables. When we explore the relationship between two variables, there is often a temptation to conclude from the observed association that changes in the explanatory variable cause changes in the response variable. In other words, you might be tempted to interpret the observed association as causation. The purpose of this part of the course is to convince you that this kind of interpretation is often wrong. The motto of this section is one of the most fundamental principles of this course. Association does not imply causation.
For example, house fires and wildfires cause substantial damage when they occur. What variables might affect the extent of this damage? This scatter plot illustrates how the number of firefighters sent to fires on the x-axis is related to the amount of damage caused by fires on the y-axis in a certain city. The scatter plot clearly displays a fairly strong or slightly curved positive relationship between the two variables. Would it then be reasonable to conclude that sending more firefighters to a fire causes more damage, or that the city should send fewer firefighters to a fire in order to decrease the amount of damage done by the fire? Of course not. So what's going on here? There is a third variable in the background, the seriousness of the fire, that's responsible for the observed relationship. More serious fires require more firefighters and also cause more damage. This model will help you visualize this situation. The seriousness of the fire is a confounding variable. In statistics, a confounding variable, also known as confounding factor, a lurking variable, a confound, or confounder, is an extraneous variable that is associated positively or negatively with both the explanatory variable and response variable. We need to control for these factors to avoid incorrectly believing that the response variable is associated with the explanatory variable.
Confounding is a major threat to the validity of inferences made about the statistical associations. In the case of a confounding variable, the observed association with the response variable should be attributed to the confounder rather than the explanatory variable. In science, we test for confounders by including these third variables, or fourth or fifth or sixth, in our statistical models that may explain the association of interest. In other words, we want to demonstrate that our association of interest is significant even after controlling for potential confounders.